So I think some of you have asked for some help in the system of particles and rotational motion. So that's why I thought we will do that. Definitely, it is slightly longer chapter, and some students might find it a little bit difficult. I agree with that, but it's not as it's not like very complicated or anything like that. It's like direct formula substitution. Most of the at least more than 50-60% of the problems are direct formula substitution, and some of them you have to do a little bit of thinking, like angular momentum conservation, those kind of things. So if you understand the linear mechanics, the rotational mechanics is easy. Okay, so it's just an extension of linear mechanics. For example, I can quickly, I'll take some 5-10 minutes to quickly go through the theory here. So when you want to find the center of mass between the syllabus, they clearly say that two mass systems. So that means you should know this kind of formulas. So this is very often you'll be using this formula, MRCM, M1R1 plus M2R2. The trick here is you should take, if it is like a straight line, right? You should take one of the thing as origin. Of course, this example here is like a 2-dimension. So if it is 1 dimension, yeah, look at this. So if it is a 1 dimension, they will give you 3 kg here, 5 kg here. They'll ask you to find the center of mass. So you should take either, either one of the points as the origin, and from that you have to, take the numbers. For example, look at this. 3 plus 5 is 8. RCM is what I want to find. 3 kg, and from this point it is 4 centimeter, and 5, and then from this point it is 8, which means your answer will also be from this point. Okay, as you do some problems, I'm sure you will understand it. Very simple, nothing very difficult. Sometimes you will get this kind of cutout mass, meaning you should calculate the first mass as having the entire disk or the material, and then the second one you should take it as negative mass, meaning the mass is not there, so you have to take it as minus m. In reality, there is no such thing as negative mass, but here in this kind of thing, since it is a cutout, the first object you will assume that it has got mass, and the second object you will say that the mass has been reduced. Okay, otherwise the concepts are same. So as we do some problems, we can discuss it. Even in the previous classes, I remember talking about this. When the external forces applied is 0, you see this one, when F external is 0, then what will happen is acceleration will be 0, which means the center of mass of the velocity, right? Center of mass of the velocity will remain constant, or 0. Okay, so that means MRCM is equal to M1R1 plus M2R2. If I differentiate this, I will get MVCM is equal to M1V1 plus M2V2. It's nothing but your linear momentum, right? Momentum conservation. And if I differentiate this, I will get this one, MACM, M1A1 plus M2A2. This is nothing but your F1 plus F2. That will give you the total force, F total. Okay, as you do some problems, I'm sure it will become easy. It's not very difficult. And sometimes you will get these kind of problems. So look at this example here. So the center of mass is here. Center of mass of the boat is here. The center of mass of the man is somewhere here because he's standing at one end of the boat. So the center of mass of the system would have shifted slightly towards a heavier weight. Okay, so that means it's slightly shifted this way. But what will happen if the man starts walking on towards the other end? So he'll be coming over here. So what we find is the interesting thing here is the center of mass of the system remains the same. So how is that possible? Because there was no external force acting on it. So the man and the boat are one single system, and there was nobody pushing the boat from outside. So because of that, what they say is the center of mass of the system, you see this point and this point are exactly the same. So the center of mass of the boat has shifted this way. So how is that possible? So as you start walking, you will realize that the boat will move slightly this way. So if you calculate the center of mass of the system, it will remain the same. இருக்கா புரியாம இருக்கா? இது இம்பார்ட்டன்ட் கான்செப்ட், அடிக்கடி கொஸ்டின் வரும். ஸோ நீங்கள் எக்ஸ்டர்னல் ஃபோர்ஸ் எதுவும் அப்ளை பண்ணாதப்போ என்ன ஆகும் அப்படின்னாக்கா, இந்த பர்சன் நீங்கள் ஒரு எண்ட்லேருந்து இன்னொரு எண்டுக்கு போனீங்க அப்படின்னா சென்டர் ஆஃப் மாஸ் ஆஃப் த சிஸ்டம் வில் ரிமைன் த சேம். ஏன்னா எக்ஸ்டர்னல் ஃபோர்ஸ் வந்து 0. அதனால சென்டர் ஆஃப் மாஸ் வில் ரிமைன் த சேம். இங்கே பார்த்தா மாதிரி.
Guru, I think one girl cannot understand Tamil.
Okay, yeah, then I will stick with
in English. Yeah, please.
Okay, I will stick with English. Okay. So as we do some problems, I'm sure you will understand it. Okay, I'm just trying to show you what all the things you have to study, and you have to go back and make use of the handbook properly. The textbook is very, very confusing. So of course you can read through the textbook also. I'm not saying you don't have to read through it, but first read through the handbook and then go through the textbook also. And sometimes you will get this kind of problems where man climbing a rope in a balloon, hot air balloon. These are all slightly advanced questions. We can come back to it later. You should know the difference between moment of force and moment of couple. Force means only one force. Couple means two, equal and opposite. So very often I saw that they are asking you whether this will cause a rotational motion or translational motion. Translation means linear motion. So as you can see, equal and opposite force will cancel each other. So that means the linear motion will be 0. Whereas since this is also causing clockwise rotation, and this is also causing clockwise rotation, it will cause a rotational motion. This is what we do in a steering wheel or opening a lid of a bottle. All these things are without our knowledge. Even when you open a tap, that's what you are actually doing. So one finger will be here, another finger will be here, and you will be causing a torque. So without our knowledge, we have been using moment of a couple everywhere. And don't get confused by the name moment. Okay, momentum is different, moment is different. So moment means torque or turning effect. So another name for moment is torque. Very often I see students confusing momentum and moment. So I don't know why they're confused. Moment is different, right? Torque. In linear motion, if I say sigma f is equal to 0, what it means, it is in equilibrium. Similarly, in rotational motion, right, in moments, sigma tau is equal to 0 means clockwise moments are equal to the anti-clockwise moments or counterclockwise moments. That's the meaning of this. So either I can write as torque or moments. Okay, so that's why I've shown both the things so that students don't get confused. This one you can go through it, right? So generally we keep the fulcrum closer to the load so that this length d2 will be larger, d1 should be smaller. If that is the case, what will happen is the effort which we give here will be less. So I can easily move a rock by keeping a fulcrum like this. Okay, so this is called a mechanical advantage. So that means F2 applied is equal to, so F1 into d1 is equal to F2 into d2, just like, yeah, using this principle. So that means if I want to find F2, F1 into d1 by d2. So that means if the d2 is longer, that means F2 will be smaller. So that means I will be applying less effort to move the bigger rock. You should understand what is equilibrium, right? There are two kinds of equilibrium, rotational equilibrium and translational equilibrium. Okay, so if it is not moving at all, or if it is going at a constant speed, then we call it as linear equilibrium or translational equilibrium. If it is rotating at a constant speed, then it is called rotational equilibrium. Or if it's not rotating at all, that is also rotational equilibrium. This is coming from your previous chapters. Listen carefully. You may be confused, sir. Why are you saying that even if it is moving, it is equilibrium? If it is moving at a constant velocity, it is called equilibrium, right? Only if it is accelerating, it is not equilibrium. So whenever the force is zero, that doesn't mean that it is stationary. It may be going at a constant speed, meaning acceleration is zero, but the velocity can be constant. An important concept. Okay, these things I would say as we do some problems, it's coming in the second part. So today we can do the first part. I'm just showing you, a lot of notes is here. You have to make use of it. And V is equal to U plus AT can be written as omega is equal to omega naught alpha into T, right? I'm assuming that all of you have already studied this. Okay, people from 11th standard, if you have completed the 11th, I'm sure you have already gone through these things. Okay, so that's why I'm going a little bit faster. So don't worry about it. If you don't understand something, probably as we do some problems, it will get easier. So whatever you see in the linear motion, you can convert it into rotational motion. Okay, so if you study it side by side, it's very easy. S is equal to ut plus half at square. In rotational motion, it will be theta is equal to omega naught initial angular velocity into t, half alpha into t square. V squared is equal to u squared plus 2as. Here it will be omega squared plus omega naught squared plus 2 alpha theta. Okay. This is a very important table. Okay, so we can compare the linear motion and the rotational motion. So everything is kind of documented here. Okay. So displacement means angular displacement. Velocity means angular velocity. Dx by dt becomes d theta by dt. Acceleration is dv by dt. Here it will be angular acceleration d omega by dt. Mass means on the linear thing, the inertia is caused by the mass. In rotational motion, it is not only the mass, it is also the location of mass from the center. That's why you get mr squared, which is your rotational inertia or moment of inertia. Okay, so moment means something to do with the rotation. So you can say moment of inertia or rotational inertia. Momentum means mass into velocity. Angular momentum means angular inertia, which is I. Velocity is angular velocity, so I omega. So we represent it by the letter L. F is equal to ma becomes tau is equal to I alpha. According to Newton's second law, rate of change of momentum, which is dp by dt, is your force. Similarly, torque is defined as rate of change of angular momentum. So dl by dt. L is angular momentum. This is an important concept. Maybe I can take some, you will get a lot of problems based on this. So we can discuss that. So when you have one object coming and hitting another object, we take this as say m1, m2, and we take this as u2 and u1 initial velocity. And after collision, both of them will be moving in a different velocity, which means we take it as v1 and v2. So I'm sure all of you are comfortable with the linear momentum, right? So this is what is called conservation of linear momentum. The total momentum before should be equal to the total momentum after. Sometimes you will have only one object, okay? So that, for example, in the case of rocket, so initially it will be going with certain velocity. So that is your initial velocity. But then as the rocket is flying, what happens is the fuel, more than 80% of the rocket will be like, hydrogen and oxygen tanks. So that means a huge amount of, hydrogen and oxygen you have to carry in the rocket. So that means as you burn the fuel, the mass of the rocket will reduce drastically. So that means as the mass decreases, the acceleration will increase. So which means the velocity will increase. So that means momentum before should be equal to momentum after at a different instant. However, you should keep in mind that it is true only when the external force is zero. If this is true, then these things are true. If this is not true, these things are not true. Okay, so very often we forget to understand the condition. Okay, we forget to study the condition. We just remember only this one. So it's important for you to remember that there should not be any external force acting. Okay, so for example, in these two objects, there is no other external force coming and hitting this. The same thing is applicable in the case of rotational motion. Suppose if I have a rotating chair, and if I am sitting here, or if I am standing on a rotating table, I can have a dumbbell like this, and I can have my arms extended out, which means the mass is kept at a higher distance r. So that means the moment of inertia, right? I can assume that this person is very close to the axis. So that means r is 0 for the person. So it means the moment of inertia of the person can be assumed to be 0. So if the dumbbell is kind of very heavy, like 5 kg, 10 kg, something like that, then the moment of inertia I will be taken as mr squared. So that means the moment of inertia will be high. Suppose if I'm turning in the turntable, and suddenly if I pull this dumbbells close to me, right? If I am coming closer, right? If I keep my dumbbells very close to each other. Now what happened? The radius actually reduced. So since the radius decreased, right? The mass is same, but the radius decreases. So moment of inertia decreases. What did we say in the rocket case? As the mass decreases, the velocity will increase, right? If this decreases, this will increase to keep this as a constant. Similarly, I initial, so angular momentum initial should be equal to angular momentum final. What is angular momentum? Mass into velocity, or I into omega. So this is initial, this is final. So that means in the second case, I reduce the moment of inertia. This is reduced. If this is reduced, obviously omega f will increase. And this is the concept many sportsmen and dancers use. Ballet dancers, right? When they want to increase the speed, they will bring their body closer, arms closer. When they want to reduce the speed, the ballet dancers will extend their arms and legs, and they'll stand on one leg, and then they will extend all their legs and arms. Why? Because the moment of inertia increases, which means omega speed will decrease, the rotational speed. So check out this in YouTube or somewhere, or I will try to send it out to you. So omega will decrease. If the same person, if they want to increase the speed, what they will do is they will, bring the hands and legs close to the center of rotation, the axis of rotation. So when you bring the arms closer, then the omega will increase, or the rotational speed will increase. So this is a very important concept. You should keep this in mind. Okay. Anybody not following this? So if you understand this, moment of inertia L before is equal to L after. Okay, I think I will get started with the numerical. I have given you some good introduction. You can go through it. Similarly, you have translational equilibrium, rotational equilibrium, impulse, rotational impulse, work done, rotational work done, power, rotational power, kinetic energy, rotational kinetic energy, right? Inelastic collision in linear motion, inelastic collision in rotational motion. Hooke's law for linear spring, Hooke's law for coil spring, right? Like a turning spring, like a torque spring. Yeah. If you see a spring like this is called the linear spring because compression will be in the linear motion. If you see some other type of springs like coil springs, this is like a rotational thing. Another type of spring you must have seen is girls when you are using this what do you call this in your it's not hairpin, what do you call that, like hair clip, right? In your hair clips, if you see inside, right, you will see some kind of a spring like this. So when you press this, you will see that it is kind of opening in the opposite direction. So that means it's not a linear motion, it is a rotational motion. So try this out. I'm sure all of you have got a hair clip in your home. Okay. So that is what is called a rotational spring or a coil spring. Okay. So definitely, not an easy chapter. As you do some problems, please let me know. We can, come back and, go through the theory. But you should know some basic formulas like, for a ring, moment of inertia is mr squared. For disk, it is mr squared by 2. For a rod, it is ml squared by 12. If you want to rotate it about this end, it will be ml squared by 3. Okay. If you want, I can explain you a little bit here. If you take a rod like this, and if I want to find the moment of inertia, this will be about this axis, we'll say it is ml squared by 12. We have some derivations, it's given in the handbook, you can go through it. But so from here you see the masses are at equal distances on both the sides. But suppose if I want to rotate it about this axis, then what will happen is the moment of inertia, will it increase or decrease? What can you say about the masses? Is it farther from the axis or closer to the axis? Some masses here. Is it closer to the axis or farther from the axis? Anybody?
Far from the axis.
Far from the axis, very good. So that means the moment of inertia, will it increase or decrease? Will it become difficult for you to rotate?
Increases, sir.
Yeah, moment of inertia will increase. Okay, so that's why it becomes divided by 3. So obviously this is a bigger number and this is a smaller number. Okay. Similarly, if you take a ring, if you take a ring like this, you can do some simple integration. It's given in the handbook. So if I want to find the moment of inertia for this, it will be mr squared. But if you take a disk, meaning this entire thing is mass, right? Material. Then it will not be mr squared. It will be masses, some of the masses, not all the mass is concentrated here in the rim. Some of the mass is kept over here. So that means it is coming closer to the center. If the mass is coming closer to the center, moment of inertia will increase or decrease?
Decrease, sir.
It will decrease. That's why if you go and check the formula, you will see mr squared by 2. Okay, so you should understand that ring is higher, disk is lower because mass is distributed or mass is closer to the axis. So if you understand this logic and study, you will not make mistakes or you will not interchange the formulas. Very often students will get confused whether it's ml squared by 12 or ml squared by 3. If you understand this logic, you will know which one is higher and which one is lower. Okay. We cannot go through the entire theory right now. We can do the problems and you can go through the theory. And then, I've given you a lot of concepts here. You can go through this and whichever is applicable in the problems, we can, make use of it. And I'm sure, as we do the problems, I'm sure it will become easy for you. So don't worry about it. It's all just a matter of practice. Okay, so the more you practice, it will become easy. So let's do few of the problems, easy ones, and then we can progress to a little more difficult ones. In carbon monoxide molecule, the carbon and oxygen atoms are separated by a distance. Okay, so carbon is like this, oxygen is like this, separated by a distance d. I know that carbon is C12. Oxygen is O16, is that right? 8 plus 8, 16. So that means the center of mass is not going to be at the center. It's going to be slightly shifted towards the heavier mass. So this intuitively you should know that even before you start the problem, you should know that the center of mass is not at the center. It's going to be slightly this way. Only if these two are equal, then it will be at the center. Distance of the center of mass from the carbon atom. So let's take it as x. The distance is given as 1.12 into 10 power minus 10 meters, which is angstrom. So this is your center of mass. So very simple, mRCM is equal to m1 r1 plus m2 r2. I know that carbon atom has got something like 6 protons and 6 neutrons, which means total 12. So that means it will be atomic mass unit will be 12U, not kg. And then this will be 16U. RCM is this distance x from the carbon atom. M1 is 12U, carbon atom. R1 is, I'm going to take this as my origin. So that means everything should be referred from this point. So that means this is going to be 0. M2 is 16U, atomic mass unit, not kg. R2 is this location, D, from here to here. U will come out, so U will get cancelled out. This will become 28, 12U. This will become 0. This will become 16, D. I want X, so X is equal to 16 by 28 into D is your 1.12 into 10 power minus 10. Any approximate answers? Anybody got it? Anybody have any answers? I'm surprised nobody did it. So it will be 4 by 7, right? 4 by 7 means 4, 7, so 40. So 0 point something multiplied by. So I can cancel 7 and 1.12. Anybody having a quick answer? .64. That's your answer. Okay, very simple, nothing very difficult here. Anybody having any doubts? That's an easy one. Anybody can tell me the answer? Second one. It depends upon the mass, it depends upon the position, it depends upon the relative distance, so it doesn't depend upon the force, right? We didn't use anything like a force here. So that means B is the answer. It does not depend upon forces. This is like, it's smooth horizontal surface. So this is coming under rolling motion. When we study rolling motion, probably you will understand better. But I can tell you that so this height is h is equal to 0 from the ground. This height is h is equal to r. This height is h is equal to 2r. The interesting thing is, you should know that for rolling, right, it's coming in the last part of the topic, this chapter. So we'll come back to it later. But for rolling, right, only if you have some friction in the ground, you will be able to roll. Otherwise, what will happen is, whenever there is no friction, the wheel will just slide through. This you must have experienced in cars. When you have proper friction, it will roll. When you have some oil in the road, you will see that it will be slipping, right? So slipping means it's like sliding. It's not rolling. Okay, so that means smooth horizontal surface means it cannot roll. It has to slide. So since it has to slide, it doesn't matter where you apply the force, right? Whether you apply it here or here or here, it's going to slide down. If it was rolling, then this will have an effect. Okay, so I would say the acceleration will be same, whatever h may be. So for now, understand the basic concept of rolling, right? So you should have friction for rolling, otherwise rolling will not happen. This involves a little bit of integration. The linear density of a rod of length 3 meters So I'm going to call this as x is equal to 0 here and x is equal to 3 meters here. So linear density is proportional to x. So linear density is proportional to x. So k into x. Where x is the distance from one end of the rod. The distance of the center of gravity of the rod from this end is, so center of gravity means you can calculate the center of mass. So what this means is here it is lighter, here it is heavier, here it becomes even more heavier, here it becomes very, very heavy. So what this means is as you go along the x, right, the linear density, mass per unit length increases. So that means for the same 1 centimeter, you will have more mass. That's the meaning. So that means it's a varying, mass is varying, it's not uniform. So you have to use some integration methods. Everyone understanding the problem? Only if you understand that it is not a uniform rod, you'll be able to apply the integration concept. So that means we take a small region, which I'm going to call it as dx. Where is this located? It's located at a distance of x. And this small region is going to have a small mass dm. So that means according to this, linear density is mass by volume. Sorry, mass by length, not volume. So that means dm by this small distance, small length dx is equal to kx. Why are we doing this? Because if I want to rewrite this formula, which we studied as MRCM is equal to M1 R1 plus M2 R2 plus M3 R3. So that means this will keep on going. So that means I have to calculate for each small region and then I have to multiply it by the distance. So we use integration here. So I can write this as sigma mi into ri. I stands for like an index. Okay. So that means I can rewrite this as in integration. The same thing can be written as take a small mass dm and multiply by the x. And like that you have to do it for x is equal to 0 to x is equal to 3. So if I do it for each small element, I will get the total here. That is the meaning of sigma or integration. Similarly, this is total mass. Okay, I cannot simply write as m. Again, I have to integrate it to find the total mass. So that means the total mass, I'm going to keep the RCM location outside. Integral of dm. Again, I have to integrate it from x is equal to 0 to x is equal to 3. That's all. After this, it's very, very easy. So integral of dm, so dx comes here. So it will be kx into dx into x. So that means this will become x square. So I want RCM. So bring it on this side. So integral of dm. dm is nothing but kx dx. K is a constant, so it will come out and get cancelled out. So if I integrate this, I'll get x cubed by 3 x squared by 2 0 to 3. This will become 1 by 3, 3q minus 0. For your benefit, I'm just showing all the steps. Otherwise, you can skip some of the steps. So 3 squared and 3 squared will cancel. So I'll get a 3 here. 3, 3 will cancel. So this 2 will go to the top. That will be only 2. So the RCM is 2 units. So that means 2 meters will be the correct answer. So if it looks a little bit complicated, don't worry about it. Okay, so take it down. As you do some problems like this, I'm sure it will become easy. Tatvatika, are you okay?
Yes, sir.
Okay, so all these things are neat questions. So they may ask you these kind of integration based questions. Okay, so be thorough with it.
Okay, sir.
Maybe they will change this rod into a hollow cylinder. So again, you have to follow the same logic only. So the same method, but only thing, instead of a rod, it will be like a hollow, or they may convert it into a what do you call, like a cuboid or something, right? So if you know the method, you can apply it for different shapes. Anybody having any doubts, any questions? So this is what we use for individual masses, but if it is like a continuous distribution, we call this as continuous distribution in mathematics, because mass is everywhere, it's like continuously distributed. So in that case, we use integration. If you have any doubts, please stop me. Otherwise, I'm assuming you don't have any doubts. We'll keep moving on. Two bodies of mass 1 kg and 3 kg have position vectors. The center of mass of the system has a position vector. So I think at the very beginning we talked about this. So position vector means from the origin. So let's say I have a mass here, and let's say I have another mass here. So the line joining them is like this. This is position vector R1 vector, position vector R2 vector. The center of mass, let's say somewhere here. So that means this is my center of mass. So that means we will call this as RCM. After that, simple formula, same formula again and again, nothing very difficult. Center of mass problems are very, very easy. Okay. Why are we putting a vector? Because now it is not a straight line, it is in 2 dimensions. So that means I have to use the vectors. This is my origin. 1 kg plus 3 kg. So 1 plus 3 total mass. RCM is what I want. M1 1 kg. R1 I plus 2j plus k plus 3 into minus 3i minus 2j plus k. Simplify this, we'll get the answer. So this will be minus 9, so minus 8i. This will be minus 6 plus 2, so minus 4j. 3k plus 1, so it will be 4k. This 4 and this 4s will cancel, so RCM is equal to minus 2i minus j plus k. So minus 2 minus j plus k. Yeah, so that's my answer. Okay, very, very simple if you get this idea. So whether it is 1 dimension, 2 dimension, 3 dimension, doesn't matter at all. If you use this formula, you will get the answer. Very simple. Two particles which are initially at rest move towards each other under the action of their internal attraction. If their speeds are v and 2v at any instant, then the speed of the center of mass of the system will be. So two masses are coming closer to each other because of their internal attraction. So why this word is important? Internal attraction means, is there an external force acting or not acting? External force. Nobody wants to answer. Okay. So internal attraction means no external force, right? So no external force means, I told you I can use the formula MRCM is equal to M1R1 plus M2R2. I told you if I differentiate this, I will get MVCM is equal to M1V1 plus M2V2, right? So center of mass, since there is no external force, right? Center of mass will remain the same. It's not going to move at all, because when I differentiate this, I will get MACM is equal to M1A1 plus M2A2. So that means since external forces are zero, this ACM will become zero. That means the velocity of the center of mass will be zero. So it will not move anywhere. Any doubts? Okay, this is on the x-axis, so I'm going to leave it to you. You can try it yourself. This is the boat example which I was explaining you. When the man walks, right, the center of mass of the boat remains the center of mass of the system remains the same. So that means the center of mass does not move at all. So go through this. So I have given it in the handbook. So the answer is C here. This is also easy one. The center of mass and center of gravity will not coincide all the time, right? But the torque will be. So maybe I can explain it. Center of mass of a body always coincides with the center of gravity, not necessarily. So this is wrong. Center of mass of a body is the point at which the total gravitational torque on the body is zero. This is correct. So if I take a rigid block or a notebook, if you put your fingers over here, right? If you try to put your fingers like this, what will happen? You will try to balance it. So what you are actually doing is the torque on this side. This is gravity is kind of trying to pull it down this way. The gravity is trying to pull it down this way. It's trying to pull it down this way. It's trying to pull it down this way. So we are finding a point where the torques are actually balanced. If I put my finger over here, this torque will be more than this torque. So we want to find a point where the torques will be balanced. So that means it is gravitational torque on the body is zero. This is correct. Couple on a body produce both translation and rotational. Wrong. It doesn't produce translation. It produces only rotational motion. So that means this is wrong. Mechanical advantage greater than 1 means that small effort can be used to lift a large load. So I think I showed you this in the handbook, the rock example. So if you had a big rock here, if I take a fulcrum here, the effort here will be minimum and the mechanical advantage is greater than. So d2 by d1 is your mechanical advantage. So d2 will be bigger. Okay, so if you don't follow, you can go back and check it in the handbook. I think it was there in the very first pages. Yeah. So mechanical advantage is defined as F1 divided by F2 d2 by d1. That means the d2 should be longer, d1 should be smaller, which means it is greater than 1. So B and D is the correct answer. Yeah, I think this you can try it yourself. 5 kg, 1 meter long. So very easy one, nothing very difficult. Two racing cars of mass m and 4m are moving in circles r and 2r. So r and 2r. If their speeds are such that each makes a complete circle in the same time. So that means if a car starts here, by the time it completes one circle, this car is also making one full circle here. So what this means is the time period is same. If time period is same, they're asking you to find the angular speeds. So the angular speeds is t is equal to 2 pi by omega, right? You must have studied omega is equal to 2 pi by t. That means t is equal to 2 pi by omega. If I say t is same, omega is also same. Omega same means 1:1. So very simple, nothing very difficult. If this is not making sense, imagine your fan blades. So by the time this point completes one rotation, this point also completes one rotation. That means A and B may be having different velocities, linear velocity. P is equal to r omega. The omega remains the same because it has to complete one full rotation. Okay, you cannot expect the A to be completing later than B or B later than the A. That is not possible. That means the linear velocity may be higher, but the angular velocity will remain the same. So you see the radius here is smaller, whereas the radius here is bigger. So that means as the radius increases, the linear velocity will increase. Okay, so very often think about the ceiling fan, you will get the idea. One revolution is 2 pi radians. 1 minute is 60 seconds, so that means this will become radians by second. So do the math. So 3 pi radians per second is the correct answer. Okay, nothing very difficult, very simple. Same thing, 120 revolutions per minute, so I'm going to leave it to you. This is also same, like, 1:1 you will get, because they said the completes the circle in the same time. So read through it yourself later. Okay, so it's same like what we discussed. So it will be 1:1. A wheel of radius 1 meter rolls forward half a revolution on a horizontal ground. So that means there is a wheel here. And let's say this is the ground. So that means point A. So it's rolling down like this. So it's coming to a different point. So the A goes to the top. So this point has come down here. Because read this, rolls forward half a revolution. So that means if it was full rotation revolution, A would have come here. Since it is half revolution, A is here. Okay. So making sense out of the paragraph is the first step. Magnitude of the displacement of the point of the wheel initially in contact with the ground. So that means they're asking to find the displacement. I know that this is r plus r 2r, which means the radius will become, this distance will become 2 meters. This, I know that if this point has come down, it would have completed 2 pi r. Since this is half a revolution, it will be 2 pi r into 1 by 2, half of it. Which means 2 cancels, so pi into 1 meter, which is pi. That means if I want this displacement, it's nothing but your root of pi squared plus 2 squared, which is 4. Okay, so getting this drawing is the difficult part. Once you get the drawing, it's very, very easy. A wheel has angular acceleration and an initial angular speed. So that means alpha is given, omega initial is given. In a time of t is equal to 2 seconds, it has rotated through an angle of, so they're asking you to find the theta. So acceleration given, initial velocity is given, s is asked. So the formula that comes to my mind is s is equal to ut plus half at square. However, we are not working with linear motion right now. We are working with rotational motion. So that means instead of linear displacement, it is rotational displacement, which is your angle. Instead of initial velocity u, it will be initial angular velocity omega I. Time remains the same, half. Instead of linear acceleration, it will be rotational acceleration, okay, angular acceleration, t squared. That's all. If you get this idea, you can solve this very, very simple. If you don't get this idea, you cannot solve this. Okay, you will think that it is very difficult, but actually it's a very, very easy problem. So omega initial is 2 radians per second. Time taken is 2 seconds. Half angular acceleration is 3, 2 square. Simplify this, you'll get the answer. Any answer? 2 cancels, so 3 into 2, 6, 6 plus 4, 10. This is also very similar to what I did right now. Only thing you have to use V is equal to R omega. Maybe for your benefit, I will do this. Because sometimes they will not give you the omega, they will give you the linear velocity. That means you have to use V is equal to R omega. Attains a velocity of V naught in the nth round. So that means the theta distance traveled or the angular displacement happened is nth round, which means n into 2 pi. For 1 revolution it is 2 pi. For 10 revolutions it will be 10 into 2 pi. So n into 2 pi. Attains a velocity of V naught. So that means, so I know V is equal to R omega. So omega final is equal to V by R. So V naught by R. So S is given, V is given, U is given. That means alpha is asked, which means time is not involved. Whenever time is not involved, I will use this formula. V squared is equal to U squared plus 2AS. And instead of this formula, I can use omega final square is equal to omega initial square plus 2 alpha into, instead of displacement, it is angular displacement, theta. That's all. So if you know to identify these formulas, it's very, very easy. Omega F is V naught by R. So V naught square by R square. Omega initial is 0. 2 alpha is what is asked. Angular displacement, very often you will make the mistake of taking this, making some mistakes here. 1 revolution is 2 pi, n revolution be n2 pi. That means if I want alpha, alpha is equal to 4 n pi will come on this side. So V naught squared 4 n pi r squared. 4 n pi r squared. So that's your answer. Here you have only r, here you have 2 pi, so this is the correct answer. You see, again and again they are asking you this, so it's like 1:1 because I told you time period same means omega is also same. Ceiling fan, the inner radius and the outer radius, inner points and the outer points complete the same rotation, right? So omega is same angular speed. This is coming in rolling motion, okay? So So, but for now, you should understand that angular momentum is conserved. Okay, kinetic energy will not be conserved when you have some slipping. So we'll come to that later. Okay, we'll do the first part and then we'll do the rolling motion later. So for now, take it down as B is the correct answer. Kinetic energy will be reduced. And angular momentum above the center of mass is also wrong. It should be above the point of contact with the ground. We can do some more easy ones, and then tomorrow also we'll have the class, so try to join it. You see, this is a very lengthy chapter. Okay, so I think we have something like 90 questions or something. Yeah, 92 questions. So you have to practice a lot, especially students who are going to take the Neet this year, right? So definitely important chapter for your Neet, so practice it properly. So far, I would say you didn't face any difficult problems at all. It's just direct formula substitution. If you know the formula, you can do it. If you don't know the formula, you cannot do it. So if you are scared, or if you think that it is very hard, that is not true, right? It is just your own imagination. A particle of mass is moving with a uniform speed along the line, magnitude of the angular momentum of the particle. So this is an important type of problem, so listen carefully. So if I take any point, let's say in this case they said origin, y is equal to x plus 4 means the line is going to be like this, because 4 is the intersection point, y intersection. So y is equal to x plus 4. So the particle is moving in this line, the velocity v, the mass m. So there is a concept here which is, I don't know if I have given it in the handbook. I'm sure I have given it somewhere in the handbook. Maybe towards the end, I think I have given it for some entrance exam based question. Yeah, so look at this. So wherever this particle is, right, this perpendicular distance will remain the same, whether you have it here or here. The momentum about a given, angular momentum about a given point will be same, because mass and velocity will be same and this perpendicular distance will be same. Okay, I can say that one more time. So whether it is moving here or whether it is moving here, the linear distance is still the same. This is the perpendicular distance, d. Okay, so that means whether you are here or even here, the d remains the same. So generally we call this, instead of perpendicular distance d, we call this as a r vector, and this will be the p vector. P vector is mass into velocity. So that means if I want angular momentum, angular momentum L is equal to R cross P. This is similar to your torque is equal to R cross F. So this is linear, multiplied by the radius, you will get the rotational. This is linear momentum, not pressure, right? Linear momentum. We are not talking about pressure here, so don't get confused. So if I take a linear and then multiply by the radius, I will get the angular. So this is linear momentum, this is angular momentum. Okay. So go back and check that table which I discussed. So that means mass is given, velocity is given. So finding this is very easy. But only thing I have to find here is this r, perpendicular distance. So perpendicular distance, if I know a line and then if I know the point, in your mathematics, I think you have something like perpendicular distance formula. I think it will be like a x1 plus b y1 plus c divided by square root of a square plus b square. Anybody remember this formula? Perpendicular distance between a line and a point. Okay, so this is your line. Ax plus by plus c is equal to 0 is a line, and the point is your x1 comma y1. So that means I'm supposed to substitute this points over here. That will give me the numerator, and then I have to take the square root of the coefficients. That's all. So find out r multiplied by m into v, you will get the answer. A is 1 here. So the line over here will be 1x minus 1y plus 4 is equal to 0. So 1 into 0, x1, I want it up on the origin. So that means 0 minus 1 into y1 is 0 plus c is 4. Square root of a square plus b square. So a square plus b square. This becomes 4 divided by root 2. So that's my perpendicular distance. Okay. That means the linear momentum is equal to r cross p, but they are asking you to find the magnitude. So r into m into v. R is 4 by root 2. Mass is 5 kg, I think. 5 kg and 3 root 2. Root 2 cancels. So 15 into 4, 60. And this is angular momentum. So 60 units. Yeah. Okay, so only if you understand this diagram, you will be able to do this. This is direct mathematics, right? So nothing very difficult here. Any questions, anybody? Tatvatika, follow பண்ணிட்டு இருக்கீங்களா?
Yes, sir.
Okay, no doubts so far?
No, sir, no doubts.
Okay, what about Vedant? Anybody else? Vedant, Kavya? Ilya, Kavya Lankano? Kingla Ilya?
Sir, could you please explain the diagram once more?
Which diagram?
Sir, now we solved this diagram, sir.
There is some mass here which is going at a velocity v. They are asking you to find the angular momentum about a point p. That means, should I take this length or should I take this length? Or should I take this length or should I take this length? Which length will you take?
Sir, the last one, yeah, the 90
perpendicular distance. So that means this
yes.
is my perpendicular distance. Okay. Why? Because when you take R cross P, this is nothing but your P. So P is equal to mass into velocity. So even if you take this as my R vector, what will happen is when you take the cross, it will be the theta here. So R sine theta, so R cross, so R will be here. So I think this will become the theta. Okay. You have to draw this so many times, only then this will make sense. இப்படி வரும், இங்கே ஒரு ஆர் இருக்கும், இங்கே ஒரு பி இருக்கும். பட் ஆர் கிராஸ் பின்னாக்கா என்ன பண்ணணும்? யூ ஹாவ் டு attach the tails together. So that means R is here, P is here. And that is my angle, R cross P. That is my theta. So the theta will be somewhere here. So if this is theta, this is also theta. So when you take R cross P, you will get the sine theta. Sine theta is your opposite. So that means what will happen is you will always get this perpendicular distance. Are you getting the idea?
Yeah, yes, sir.
So in the handbook, you can go back and study this handbook. Okay, it's the same thing I explained here. So no matter if the particle is moving, even though the particle is moving, right? If it is moving in a straight line, the theta will change, but the R perpendicular will not change. Because of that, the angular momentum about a point will not change for any body which is moving in a straight line. Angular momentum is vector axial. I don't know what they mean by polar, but it's like it's the axis, right? So that means angular momentum it's a vector and it is through the axis. Scalar not correct, so I think I will choose A. Angular momentum is nothing but mass into velocity, so I into omega. So that means this is the correct answer. A couple produces purely rotational motion, right? I already explained you the concepts. So linear rotational, wrong. So it doesn't produce linear. This is an important type of problem, ladder problems. So you should be thorough with the ladder problems. Very often they'll ask you some ladder problems. And it's nothing but moments, right? So if you know the clockwise moments is equal to the anti-clockwise moments, it's a very simple problem. Get some water. A weightless ladder 20 feet long rests against a frictionless wall at an angle of 60 degrees. From the horizontal. So that means from the horizontal it is 60 degrees. So this side it is 60. So that means this is also 60. $20 feet long, so this is 20 feet. Generally, it should be meters and kg, but to confuse you, they given it in feet and pounds, like British units. A 150-pound man is 4 feet from the top of the ladder. So that means it's somewhere here. So this is 4 feet. So that means the man is standing here, which means it's going to put some load here. Horizontal force is needed to keep it from slipping. Choose the correct magnitude of the force. So you see, when somebody is standing here, obviously the ladder will try to come this way. It will slide this way. They said this is frictionless wall. So frictionless wall means very, very important. Note it down properly. Okay, very often you will use this. You will have a normal reaction. Normal reaction will always be there. But the friction will not be there because F is equal to mu into N. Since they said mu is 0, you will not have any friction. But normal reaction, definitely it will be there always. I'm going to take this as point A and this as point B. Same thing again. There will be a normal reaction here, NB. And they are asking you choose the correct magnitude of the force, which is a horizontal force. So that means somebody has to keep it this way, which is your FB. Any doubts so far in the diagram? So they said weightless ladder. So that makes our life much easier because if they said there is a weight for the ladder, then I have to include one more W here. Because from the center of this, I will take a W. But luckily in this problem, they didn't say weight is there, so weightless ladder. So that means I don't have to worry about weight of ladder. That's all. So that means somebody is putting some load here. There is a normal reaction here, normal reaction here, and then the horizontal force to keep it from moving this way. That's all. If you understood this, you know that this and this should be equal and this and this should be equal, right? Because there is no other force in the vertical direction. So NB, if I'm not convinced, I can go step by step. Sigma F vertical is equal to 0. That means NB minus 150 pound is equal to 0. Actually, I should multiply by gravity, but to keep it simpler, right? Since their answer is given in pounds, I'm not going to multiply by G. Usually, you have to multiply by mass into gravity. So in the exam, you don't have to write all these things. Only for your understanding, I'm writing it. You could have directly said this is equal to this because there is no other force in the vertical direction. Similarly, look at this. NA and FB should be equal. So I want to find FB. How can I find FB? I don't know NA and B. I have to take some moments, right? So I can take moments about this point. I'm going to take either I can take moments about this point or this point, A or B. Okay. If I take moments about A, I have to deal with 1, 2, 3, 3 forces and multiply by the distances. If I take moments about B, then these two will cancel. And I have to deal only with 2 forces, which means taking the moments about B will be faster. Okay. So since they said it is in equilibrium, I can say sigma of the torque or sigma of the moments about point B is equal to 0. That means these two forces are passing through this point, which means it will become 0. And NA multiplied by this distance, perpendicular distance. This is 20 feet and then 60, so sine 60. Anybody not following? Because this is the perpendicular distance between this force and the point. So that means the line of action of force is this way. So I should take this distance, this height, which means this is 20, this is sine 60. So 20 into sine 60 will give me this height. So this is clockwise, this is anti-clockwise. So that means minus 150 into this distance. So this distance will be, this is 4 feet, so that means this must be 16 feet. That means this will be 16 multiplied by cos 60. Okay, so that means 150 into this distance. So 150 into 16 into cos 60. That is equal to 0. What happened to NB and FB? Because it is passing through the point B, it will become 0. Because the perpendicular distance will become 0. Let's all simplify this, find out NA, that will give you FB, because NA is equal to FB. This goes on the other side, so 150 into 16 into cos 60 is 1 by 2 divided by 20 feet into root 3 by 2. Anything else I can cancel? Root 3. I can write as 5 into 3 into 8 divided by root 3, so that I can cancel this root 3 and this root 3. So I'll get 40 into root 3. 40 into 1.7 something. So that will give me around 17 into 4, sorry, 17 into 4, 28, something close to 68. If you are not convinced, what you can do is, you can take the moments, take it as a homework. So you can take the moments about point A and take this one, this one, this one, and find out the value for FB, because now you know NB. So you should get the same answer as this value. Any doubts? Only this part might be looking a little bit complicated. Only if you practice it, if you try it, it will become easy. Okay. If you listen to what I am saying, obviously it will look a little more complicated. So take a fresh sheet and try it yourself. And I'm sure you will find that it's very easy. Okay, so we have come very close to 25. So we will try to do some more in the next class tomorrow. Okay. So my suggestion is, I will upload some of the solutions. Okay. So you can go through it and then, do as much as possible. Okay. I'm not going to force you because it's a very lengthy chapter. So maybe at least try to do at least up to 50. Okay. So if it's required, we can do 2 more classes, okay, in this same chapter. Is that okay, everyone? Vedant, are you okay?
Yes, sir. Yes, sir.
Shalvan following?
Okay, Guru.
Sure,
Thank you.
sir.
Okay, sir. Yeah. Roshini following everything?